everyone. Today I'm going to talk about kinematic equation. What is speed? Well, speed is how fast or slow something moves. And in the SI unit, speed is the unit of speed is meter per second. Speeds may be constant, but usually it is varies from moment to moment. So, how to calculate speed? Well, the average speed is the distance over time. Okay, like you go a car trip with your family and the distance is 120 miles and you drive, it takes 3 hours to drive that far. So what is your average speed? So it's just 120 divided 3 is equal to 40 miles per hour or mph. So there's a question, average speed while changing directions. First, the distance is 10 miles from your home to work. And you drive to work at 40 mph and you drive back by 10 mph. What's the average speed? So some people think it's simple. So 40 plus 10, 50 divided by 2 is equal to 20. 5, okay? But actually it's not the correct answer because the time is different. So how to calculate it? Well, first, okay, so it's very simple. Okay, so actually we don't need the time. Okay, no, we don't need the distance. We use it by s, for example. Okay, so the whole distance is 2s over 1. This is the whole distance over the time you drive to work plus the time you drive back. So the time you drive to work is s over 14 plus the you drive back is s over 10. So they have a least common multiple, which is 14. So which is equal to, so it's 14 is a denominator over 5x because it is 4 times x plus x. Okay, so it's 5s. Okay, and then how to calculate it? Well, we know one thing is that you just multiply the middle is the denominator, and you just times the outside, which is the numerator. So it is 5s, and it is 18s. Okay, so it's equal to 16. Yes, it's 16. So you just cancel the s. So 18 divided by 5 is equal to 16. And then we just cut the okay. So the answer is 16 mph. Instantaneous speed and average speed. Well, what is instantaneous speed? Instantaneous speed is a speed in a given time or moment. It varies from moment to moment. And the average speed is the average speed distance over time. Speed and velocity. What is speed? Speed is distance over time, while velocity is delta x over delta t. So what is the delta x? Is the displacement. So speed is a scalar quantity and they have no direction, while velocity is a vector quantity where they have a direction. You can see the picture, okay? So you move from A to B, the distance is the blue line. So the distance is very long, as the displacement is shorter, just the red line is the displacement. And remember, velocity is a vector quantity, so it has a direction. So speed is just a magnitude, while velocity is a magnitude plus a direction plus. So speed and velocity. Now, soon a car moves 100 miles toward east and it takes 10 seconds. So what is the average speed? No, average speed and average velocity. So speed is 10 meters per second. While velocity is 10 meters per second toward east because it plus a direction. Constant velocity. What's a constant velocity? Like you just keep moving like maybe 1 meter per second. Now you can find the velocity is 30, okay? And the time is 6 seconds. So the displacement is the whole picture, the yellow part. So it's just the area. Yes. So it's equal to 180 because 30 times 6 is equal to 180. What is acceleration? Acceleration is a changing time. And it's the vector quantity, okay? And magnitude, and that means they have a magnitude plus a direction. So the speed is only a magnitude, right? Okay, so suppose a car just is speed from 0 second, it's not moving, just stay at rest, and then it to 16 meter per second is in 3 seconds, so it's very, very fast. What is the acceleration of a car? So acceleration is equal to the VR minus VI over the time, t. So 16 minus 0 is equal to 16 over the 3 seconds, so it's equal to 20 meter per second square. So what is meter per second square? It's just a unit, SI unit. Meter per second square. Okay, so another example, like maybe a cyclist just is riding a bike and he's going to win, and then he just stop. Well, it's in the final, and he stopped from 6 to 2 in 4 seconds. So that's 2 minus 6 is negative 4 over 4 is equal to negative 1. Because it's stopping, so it's negative. Or you can just say like that. 1 meter per second square backward. It's the same. What is a constant acceleration? Constant acceleration is acceleration it's same, just 2, just add 2. And initial velocity is the VI is the velocity you start, and VF is a final velocity. That means in end of velocity. So what is the kinematic equation? So there's 3 equations. VF is equal to VI plus AT. S is equal to VIT plus 1/2 AT squared. VT squared is equal to VI squared plus 2AS. So actually, the T, okay, is time. Yes. Okay. So what is VF is equal to VI plus AT? Why? So first we know the equation. A is equal to VI minus VI over T. Okay. So I will write it right here. A is equal to VF minus VI over T. So we write here. So AT is equal to VF minus VI. So VI goes here. So AT plus VI is equal to VF. So that's why it comes from. Okay, so there's an example. Rocket is launched, and the initial velocity is 30 meters per second, and then when he reaches 3 seconds, then he falls down. Okay, so what is the acceleration? So let's write it. Okay, so now we know the VI initial velocity is set as 30, and the VF is equal to 0 because it's not moving, and her T is equal to 3. So VF0 is equal to 30 plus 3A. So 3A is equal to 30 negative 30. So A is equal to negative 10 because it's just slower because it's the Earth's gravity. Okay. so it's the right acceleration. So another equation, s is equal to vit plus 1/2 at squared. So why? So we already tell that this is 180, right? So it's just the area is the displacement. So S stands for the displacement, right? So just times the two sides together. So it's the area is the displacement. So now S is the displacement. So when you're not moving and suddenly you move, it's the red part like that. And then how to calculate it? So we know we just add the triangle plus rectangle. So rectangle is vi times t, while the triangle is t times vf minus vi. So we can write it. Yellow part is equal to vi times t or vit. Okay. So square is equal. The triangle is equal to 1/2 vf minus vi times t. Okay. So why we replace the vf minus vi into at? So again. So first into So it says that we know that vm is equal to vi plus at. So vi goes here. Vf minus vi is equal to at. So we know the equation. There's a vf vi times t. So we replace this into this. So we replace it by times t. So it's at squared. That's why. And then you add this together. Vit plus 1/2 at squared. Okay. Or you can use the trapezoid formula. S is equal to vi plus vf times t and divided by 2. Okay, so it's trapezoid formula. So it's the same. So because that we can replace it too. So because they replace it into at. So that's why. So that's why it's a little different. That's just because it replace it, and the trapezoid formula didn't replace it. Okay. Okay. And S is equal to vit plus 1/2 at squared. So here. Okay. So if the acceleration of just a boat is 4, okay, and it starts at a rest, that means it's not moving, and then acceleration is 4 meters per second squared. And then what is the displacement after 6 seconds? So another. Okay. So her vi is equal to 0. Okay. And her t is equal to, it says 6 seconds. And then her acceleration is 4. So it's equal to 4. Okay. So how to do it? First, what is the equation? So the equation is S is equal to vit plus 1/2 at squared. Okay. So S is equal to vi is equal to 0. So anything times 0 is 0. So 1/2 at squared is equal to a is 4. So 2 times t squared. So t is equal to 6. So it's 72. So then the answer is 72. Another equation. vf squared is equal to vf squared is equal to vi squared plus 2as. So why? The first thing we need to know. Okay. Vf is equal to vi plus at. So first, we just get the vi here. Okay. So it is equal to vf minus vi is equal to at. We already know that. So then we just go the a here. So vf minus vi over a is equal to t. So now with the trapezoid formula, there's a t, we will replace it and become v1/2 vi plus vf times vi minus vf. So there's a formula that if you calculate y is plus 1 is negative, it becomes v squared minus vi squared. Vf squared minus vi squared. Okay, so that's y, and then 1/2. So then y the formula comes. And next one, this, okay. So what's this? This is some diagram. The first one, you're not moving, just stand right here. Like that, okay. So your x and t diagram. So your x didn't change over time, right? Because you're not moving, and your t, your time is no longer that. So it's just nothing. Another one, so your velocity is 0 because you're not moving. And your acceleration is 0 because you're not changing speed. It's faster and faster or slower and slower. What is that? That you just keep moving at 20 meters per second like that. So your diagram looks like that. Because you just keep moving far, 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 far. Okay, like that. And actually your velocity just stayed the same. So it's same. And your acceleration didn't change because you're not getting faster or slower. It's the same speed or velocity. So if you are getting faster and faster and faster and faster and faster. So actually it's not really looks like that. It's just sometimes it's just a straight line. But actually this is because people maybe is going backward, and then there's more pressure to pull him back, and then so first it's getting far, 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 and then it's enough power to pull him back, and then he will just go up, just like that. Okay, so actually it's a 0 because you stayed at the same. Like you go here and then you go back and you get into the point. Okay, another is a VT diagram. So actually it's a straight line because your acceleration is same. So a straight line. So like that. And another this is your acceleration over time. So your acceleration keeps the same. So it's the same. And so this is the displacement, AT. So this is that you are getting slower and slower. How at first you just throw in a ball. A ball is just go upward, and then it's getting slower because of gravity. And then it gets slower just like a grab, and then it gets enough, and then it just go back. And then it gets slower and reach the ground. That's why. And another. So instead of just slower, 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 acceleration is same. So velocity is just slower and slower and slower and slower. And the AT diagram is acceleration is same, just slower and slower. So this is AT. Then it's nothing.